Hello, I'm Ben Whitaker. I'm Professor of Chemical Physics at the University of Leeds in the Chemistry Department. And I was asked two questions, which I think we can join together. Both carbon dioxide and water are considered to be greenhouse gases, but why should the former be considered more harmful when there's clearly more of the latter? And explain the link between the absorption of infrared radiation by bonds in carbon dioxide, methane and water, and global warming. Before we can answer these questions, we need to understand a bit of physics. Let's ask another question. What happens if we heat an object? Well, obviously, it gets hotter. But we also know from our everyday experience that things, for example, if we continuously heat something like a saucepan on a stove, things don't become infinitely hot. We always end up in an equilibrium situation in which the rate that we're pumping in heat into the object just balances the rate at which it's lost. Now, if the object in question is isolated in space, so that it isn't thermally connected to another cooler object, the only way that it can lose heat is by radiating that heat away. Objects like this are called black bodies, for reasons that will become apparent. At the end of the 19th century, a number of people began to think about what the spectrum of the heat light from such an object would look like. Between about 1897 and 1899, Otto Luhmer and Ernst Pringsheim, working together at the University of Breslau in Germany, made some very careful measurements of the light emitted by hot objects. In their experiments, they heated an iron cavity in a very carefully constructed furnace and made measurements of the light emitted through a small hole in the side of the furnace. The temperature in the furnace was very stable for very long periods of time, and they measured the spectrum of the light that was emitted through this small hole in the cavity. A spectrum is simply the graph of the intensity of light as a function of wavelength. The spectrum of light coming out of such a cavity has a very characteristic shape that, importantly, only depends on the temperature of the furnace and not what the cavity is made of. This spectrum is called the black body spectrum. Black because most of the radiation is emitted at long wavelengths in the infrared, which the human eye can't see, here running from 1 to 6 microns.